So in this lecture, we talk about the reshaping of our NumPy array, or how can we stack our NumPy array. So let's start our tutorial. So first of all, let's define NumPy array of two-dimensional dimensionality. So define NumPy array like this. So 4, 5, 6, 7, 8, 9, 0 by defining two-dimensional array. So there is an error, but error is okay. Small parenthesis. Now when I print this array, the dimensionality of array is 2, 7. So 2 rows and 7 columns. Now the shape of the array is 2, 7. Now I want to reshape the array. So how can I reshape the array? So generally you can reshape array by using a dot reshape, and now you can give the number of rows, the new number of rows you want. So for example, I want 7 rows now and only 2 columns. So when I run this, I get 7 rows and 2 columns. And previously my shape of column is 2 rows and 7 columns. So it's generally interchanged. So you can reshape your NumPy array as much as you like. So for example, I give here another 5. So now I formatting my array to 2, 8 or 2 row 8 columns. So let's run this. So the shape of that is 2, 8. So total number of elements in this array is 16, because 2 rows and 8 columns. Each rows had 8 elements. So we can reshape any number. We can use any formation of these reshape values that has factors of 16. So for example, I can use 4, 4, and my reshape new value is 4 rows and 4 columns. I can use 8, 2 like this. I can use 6, 3. So any factorial, sorry, not 6, 3, it is 16. So I can use 8, 2, 2, 8, and 4, 4. So generally, and also 16, 1 or 1, 16. So like that. So that's how can I that's how can we can reshape our NumPy array. And one thing in mind, keep in mind that the original number of elements in this case is 16. So our new reshape dimension should be the product of our new dimension should be also a product of 16. So for example, if you type here 4, 5, you get an error, because 4 multiplied by 5 is 20, and our original tensor only contains 16 elements. So when I run this reshape function, it says cannot reshape array of size 16 into shape 5, 4. So generally you cannot exceed the new dimensionality by introducing new reshape values. You should obey the rules that your previous number of elements have a factorial of this, or your new dimension of rows and columns should have factorial of previous number of elements. So that's why you should also keep in mind. Now let's talk about stacking. So first of all, let's talk about vertical stacking. So let's create two array, a NumPy array and of one dimensional. Let's create second array b NumPy dot array, again one dimensional. So when I use NumPy dot vstack function and specify a comma b in a list, our resultant value is a stacking of these two NumPy array. So b a is a, so this is our a and this is our b. So a is stacked above b. So if we change the order of it, our ultimate order also change. So now b comes top of that and a is below. So that's how we can do vertical stacking. We can also create like this, so we can stack as much as like. So we have lots of vertical stacking now. And similarly we can do edge stacking or horizontal stacking. Now the elements is stacked horizontally, so all the elements are stacked now horizontally. So that's how we can do stacking in NumPy, and also we can reshape our function in NumPy. So here is an homework for you. Homework is create a NumPy array with using random function or rand function of shape 8 by 9 and reshape the function in their possible values. So for example, 8 multiplied by 9 is equal to 72. So do practice all combination of 72, that to for example, let's do 8 9 comma 8 or any factorial that resultant multiply is equal to 72. So practice all combination and reshape your tensor or numpy array with the help of this reshape function. So that's the homework for you, and I hope you tackle this homework and try this homework. So this is all for this lecture, guys, and in the next and the last lecture of this section, we talk about loading an file from by using numpy library. So that's lecture also very interesting. So stay tuned with me and see the last lecture of this section. Until then, do your homework and enjoy artificial intelligence.